So in this video today, we're going to go over proving triangle similarity by angle-angle. So we will be proving triangle similarity with angle-angle postulate. And this is our big idea, to use similarity criteria in triangles to solve problems and prove relationships. There are several ways to prove certain triangles are similar. The following postulates, as well as side, 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 angle, side similarity theorems, will be used to prove just as side, 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 angle, side, angle, HL, and angle, angle, side were used to prove the triangles are congruent. So we're going to talk about angle, angle today. Okay, so if two angles of one triangle are congruent to two angles in another triangle, then the triangles are similar. And this is very logical. Why? Because as we can see here, angle A is congruent with angle D, right? And angle B is congruent with angle E. That means the third angles have to be congruent, right? Because those angles have to add up to be 180. So that's why this works, and it works every time for similarity. Just remember, the angles don't dilate, only sides dilate, okay? So using the angle-angle similarity postulate, we're going to explain why the triangles are similar and write a similarity statement given that TP is parallel with SR. So notice we have that TP over here is parallel with SR. So since TP is parallel with SR, angle P up here is going to be congruent with what angle? Angle R. And why? Because they're alternate interior angles, aren't they? So we're going to say alternate interior angles theorem, right? That's why they're congruent. Then it also, again, since TP is parallel with SR, we can say that angle T right here, angle T is congruent with angle S as well, right? So angle T is congruent with angle S, again, by the alternate interior angles theorem, right? And these are things that you need to notice immediately. Now, we also know that by the third angles theorem, by the third angles congruence theorem, angle PQT, this angle right here, is congruent with angle what? RQS, right? RQS. So therefore, triangle PQT is congruent with triangle RQ, or not concurrent, but similar, y'all. Notice the symbol right here, similar. So not the same size, right? By angle-angle similarity, okay? So triangle PQT is similar to triangle RQS by the angle-angle similarity. And again, we can tell that the two triangles aren't the same size, right? So they're a dilation one of the other. So the next one says, explain why the triangles are similar and write a similarity statement given that AB is parallel to DE. So again, I'm going to mark that AB and DE, okay? So since AB is parallel to DE, angle B is congruent with what, guys? Angle B is congruent with angle E, right? Again, by the alternate interior angles theorem. And then angle A is congruent with angle what? D by the right angles congruence theorem, right? This time it's right angles because they're both right angles. Therefore, triangle ABC is similar. Now let's look at the triangle. So A goes from the right angle to the two arcs to B, and then to nothing. So over here we're going to go from the right angle, which is D, to two arcs, which is E, to nothing, which is C. And again, these are similar by angle-angle similarity, okay? So go ahead and try this last one. We did that, you try A together. Go ahead and you try B yourself. Come back to me when you're done. So this one says, by the blank theorem, the measure of angle C is blank, so the measure of angle C is equal to the measure of what? So do you notice this is a right triangle here? Okay, both are right triangles, right? So couldn't we do 90 minus 43 to find this other angle down here? And it is 47, right? And then same way over here, 90 minus 47 is equal to 43. Y'all see that? So by the triangle sum theorem, the measure of angle C was 47, right? So angle C is congruent with what angle? angle F, right? And B is congruent with E. Again, why? By the right angles congruence theorem. And therefore we can say that ABC, again from the 43 to the right to the 47, is congruent from the 43, which is D, to the right angle to the 47, DEF. And again, they are similar by angle, angle. Hope I didn't say congruent, did I? Similar, 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 similar. Yeah, not the same size, okay? All right, now example 2 says explain why triangle ABE is similar to triangle ACD, and then find CD. Prove the triangles are similar. So we can tell that angle A is obviously congruent with angle A, isn't it? And that's by the reflexive property, right, of congruence. And angle B is congruent to angle C, since they are both right angles, right? Okay. Therefore, triangle ABE is similar to ACD by the angle-angle similarity. Now, it's asking us to find CD, okay? So I need you to notice that we have a little triangle and a big triangle, right? Okay, so I'm going to look at what it says here. Find CD. So we're looking for CD, so they put CD on the top. CD is right here, okay? And so it's the short side of the right triangle, and so we want to put that over the short side of the right triangle, right? So that would be x over 5, okay? And then we're going to look at the long side, right? So we're going to look at the long side of the big triangle right there. That is AC, and AC is 9 plus 3, so that's going to be equal to 12, right? So that's going to be 12 over, and what is our little triangle, y'all, right here? See it? It's 9. So we're going to do 12 over 9. So to do this, hopefully you remember you're going to cross multiply, right? So you're going to do this right here. Multiply those and multiply these. So we're going to have 9x is equal to 5 times 12. So 9x is equal to 60. Divide both sides by 9. So our x here is equal to 6.67. Okay, now you can double check that by doing 6.67 over 5 and seeing if that's the same as 12 over 9 when you reduce it, okay? So let's see if you guys can do this. You try right here. Pause the video and then come back to me when you're done. So it says prove the triangles are similar. It is given that angle S is congruent with angle T, right? Angle R is congruent with what? Angle R, isn't it, guys? Indeed, by the reflexive property of congruence. Therefore, triangle RSV. So we go from 2 arcs to 1 arc to nothing. So we're going to go from 2 arcs to 1 arc RT to nothing, RTU, by angle-angle similarity, right? Then it says find RT. Okay, so what we need to do that is we need to compare sides to sides. So I'm going to talk about little side over big, over, I should say, the side of the little triangle over the side of the big triangle. This time I'm going to do it this way. Side of the little triangle over the side of the big triangle. And that's going to be equal to the side of the little triangle, which would have been 10. And it's asking us for RT. So that's this whole length right there. Y'all see that? RT. So this time it's asking us for RT. Now we're going to talk about ST when we get this done, but I wanted to show you guys how to do this, okay? So now that, again, we're cross multiplying, right? So this is 8 RT is equal to 12 times 10. So 8 RT is equal to 120. We're going to divide both sides by 8. So RT is going to be equal to 15. And hey, what if it had asked us about ST? How would we find that? Do you see ST right here? So if the whole thing is, if it was, we're looking for ST and the whole thing was 15, wouldn't we subtract 10 from it to get ST, and that would have been 5, okay? Next one is an engineering application. So it says the photo shows a gable roof AC is parallel to FG. AC and FG, and we can see that here. See these arrows on here? AG and C and FG. Those are parallel. And it says that triangle ABC is similar to FBG. So that means our little triangle is similar to our big triangle. It says find BA to the nearest tenth of a foot. Okay, so we're looking for the whole big side. So this one's going to be a little trickier than the last one, and I'll show you why. So this time we're going to take the side, this 6.5, over this side, the parallel sides, right? So that's over 24. And this one's going to be equal to, okay, we did our little triangle, side of our little triangle, right? So this time we're just going to call this BF, right? Okay, so that's going to be BF over, and then the whole side right here, what is it going to be? Is it going to be 17 plus BF? It is, okay? So this time we're going to cross multiply. It's going to be a little bit different, okay? So we're going to cross multiply here, and this is going to be 24 BF. And that's going to be equal to 6.5 times 17 plus BF, okay? So as we work this problem, let's see what we get. So this is going to be 24 BF equals, I'm going to clean up that BF, it didn't look very good. BF equals, when I multiplied the 6.5 times the 17, I got 110.5. And then plus, wow, I can't write very well today, y'all, sorry. Our 6.5 BF. So now we need to get our BFs on one side. So we're going to subtract the 6.5 from both sides. Minus 6.5 BF. So over here we're going to do minus 6.5 BF. So when we do that, I got 17.5 BF is now equal to our 110.5. So I'm going to divide both sides by our 17.5. So BF is going to be equal to 6.3 feet. Okay. Now, the question is, it didn't ask us for BF, did it? It asked us for BA. So it's actually asking us for this whole length right here, but now we know this up here is 6.3, right? So what can we do to find BA? BA is going to be equal to what? Now, yeah, BA is going to be equal to 6.3 plus our 17, that's going to be 23.3 feet. Okay? All right, let's see if you guys can do the you try 3. Come back to me when you're done. So on this one we have AB, AC, BF, and FG. So we have AB, we have AC, big, and then we have BF, little triangle, and FG. Oh, okay, so we can set this up with big over big, or big over little. So let me show you another way to do this. Well, actually, let's just keep with what we've been doing, okay? So we can say BF over AB is going to be equal to FG over AC, right? So now we're just going to sub in what we have, okay? So BF, it says, is 4. AB is 4x. That's equal to FG, which is what we're solving for, over what? 5x, right? So we're going to cross multiply here. And I want you guys to see what's going to happen. You'll see. So 4 times 5x is equal to 4x times our FG, right? Okay. So that's going to give us 20x over here equals 4x times FG. So can't we divide both sides out by the 4x? Indeed, we can. Okay, see that? So there's those x's are going to cross each other out, right? So that's just going to be 4 into 20, which is 5. So FG is going to be equal to 5.